Welcome to our lesson on finding the angle between two lines in coordinate geometry. This is an important concept in mathematics that you'll encounter in class 11 and 12. In this video, we'll first understand what we mean by the angle between two lines, then derive the formula, and finally solve some examples to solidify our understanding. Let's start with a conceptual understanding. When two lines intersect in a plane, they form four angles. These four angles consist of two pairs of vertical angles that are equal. By convention, we usually refer to the smaller angle between the lines, which is the acute angle. Now, let's consider two lines with slopes m1 and m2. The tangent of the angle between these lines can be calculated using the formula. Tangent of theta equals the absolute value of m2 minus m1 divided by 1 plus m1 times m2. This formula gives us the tangent of the angle. To find the actual angle in degrees, we take the inverse tangent or arctangent of this value. There are some special cases to consider. First, if the lines are parallel, then their slopes are equal, meaning m1 equals m2. In this case, the angle between them is 0 degrees. Second, if the lines are perpendicular, then the product of their slopes is -1. That is, m1 times m2 equals -1. In this case, the angle is 90 degrees. Let's briefly understand where this formula comes from. Consider two lines with direction vectors v1 and v2. The cosine of the angle between these vectors is given by their dot product divided by the product of their magnitudes. When we express these vectors in terms of slopes and simplify, we get our formula for the tangent of the angle between the two lines. Now, let's solve some examples to better understand this concept. Example 1. Find the angle between the lines with equations y equals 3x plus 2 and 2y equals 6 plus 10x. First, we need to find the slopes of these two lines. For the first line, the slope is 3 since it's in the form y equals mx plus b. For the second line, we need to rearrange it to standard form first. Dividing both sides by 2, we get y equals 3 plus 5x, so the slope is 5. Now we can use our formula. Tan theta equals absolute value of 5 minus 3 divided by 1 plus 3 times 5. This gives us tan theta equals 2 divided by 16, which equals 0.125. Taking the inverse tangent, we get theta approximately equals 7.13 degrees. Let's visualize this example. Here are the two lines plotted on the coordinate plane. Line 1 in blue, with slope 3, and line 2 in red, with slope 5. As calculated, they form an angle of approximately 7.13 degrees at their intersection. Let's try another example. Example 2. Find the angle between the lines with equations 3x plus 4, y minus 7 equals 0, and 5x minus 12, y plus 8 equals 0. These equations are in standard form x plus by plus c equals 0. The slope of such a line is negative a over b. For the first line, 3x plus 4, y minus 7 equals 0. The slope is negative 3 over 4, or minus 3/4. For the second line, 5x minus 12y plus 8 equals 0. The slope is negative 5 over negative 12, or 5/12. Now we apply our formula. Tan theta equals absolute value of 5/12 minus negative 3/4 divided by 1 plus 5/12 times negative 3/4. Let's simplify. 5/12 minus negative 3/4 equals 5/12 plus 3/4, converting to a common denominator, equals 5 over 12 plus 9 over 12 equals 14 over 12 or 7 over 6 for the denominator. 1 plus 5/12 times negative 3/4 equals 1 minus 15 over 48 equals 48. Over 48 minus 15 over 48 equals 33 over 48, so tan theta equals 7 over 6 times 48 over 33, which gives us 56 over 33, or approximately 1.697. Taking the inverse tangent, theta approximately equals 59.47 degrees. Let's visualize this example too. Here are our two lines. The blue line has a slope of negative 3/4, and the red line has a slope of 5/12. They form an angle of approximately 59.47 degrees at their intersection, which matches our calculation. Let's summarize what we've learned. The angle between two lines with slopes m1 and m2 is given by theta equals tan inverse of absolute value of m2 minus m1 divided by 1 plus m1 times m2. Remember our special cases. If the lines are parallel, m1 equals m2, and the angle is 0 degrees. If the lines are perpendicular, m1 times m2 equals -1, and the angle is 90 degrees. This concept is widely used in coordinate geometry, physics, and engineering to understand spatial relationships between lines.